Hello everyone, today I will discuss Mamdani fuzzy model. Actually there are three type of model: Mamdani, Larsen and TSK model. So I will discuss Mamdani fuzzy model, and in final examination from these three model approximately 10 to 12 question will be there. So this is the overall concept of fuzzy system, how it works. In a fuzzy system there are basically four main steps: fuzzification, inference engine, defuzzification and knowledge base, that is rule base. Further, inference engine is divided into three parts. These three parts are depth of firing, implication and aggregation. So I will discuss with the help of example one by one what actually they have their own significance. So Mamdani fuzzy model, basically it is given by Professor E.H. Mamdani in 1965, right? And in this there are some rules may be single or multiple, and this Mamdani model first was used in steam engine and boiler combinations. So in Mamdani fuzzy model or in any other type of fuzzy model, basically there are two type of composition: max mean composition and max product composition. Okay, so these are the common in all these three models. So after that, in the three models we are going with these rules: single rule with single antecedent, single rule with multiple antecedent, multiple rule with multiple antecedent. So one by one in assignment 11 and 12, so question will be asked from these types of uh, concepts. So I will go with both of these two composition: max mean composition and max product composition, and single rule with single antecedent. And input can be fuzzy or input can be crisp. So first I will go with fuzzy input, after that I will go with the crisp input. So actually how it works: single rule, single antecedent, and input will be fuzzy. So rule: if x is a, then y is b. So there is only one rule, that's why it is known as single rule. uh, with single antecedent, if x is a, so this is known as the single antecedent, then y is b, so this is the output, this is output, right? So this is output. Now this is known to us, this is known to us. Now we want to calculate this one: if input x is a dash, then what will be the y? Let us consider b dash. So we want to calculate this one. So how it will be calculated? So this is the max mean composition, and after that we will consider max product, and it is the case of fuzzy input. So we want to evaluate this one. We want to evaluate this one: if x is a dash, then y is what? B dash. So what will be b dash? So in this we are having two inputs, fuzzy inputs: a solid line and a dash, which we want to calculate, right? So in the same way, if x is a, this is the input, fuzzy input, and in that case output will be b. Now I am going to superimpose this input which I want to for which I want to calculate the output. So superimposed at this particular point. So when this will intersect at this particular point, and this particular point uh, location is 0.58. This 0.58 is known as the degree of compatibility, right? So degree of compatibility, and from this we are going to take a straight line for the output which is known to us, y is b. So straight, so this will be our final output. This will be our final output, because in this case we are going to use max mean because there is only single rule and single antecedent. So 0.58 will be considered as the depth of firing. After depth of firing, and this will be the final output. This will be the final output. So this will be our final output, that is B dash. With help of next some numerical, this will be more clear to you. Max product, same numerical, same scenario. So this will be known as the degree of compatibility, and this is intersected at this particular point. So again, this will be our final output. Right now I cannot differentiate how mean max or max product is utilized. So this will be our final output. In next slides we will take care. Now input is fuzzy, but for the same case, if input is crisp, then how it work? Same rule, and right now crisp input x is 6.8. When x is 6.8, then it is uh, crossing this fuzzy set at 0.34. So this is the degree of compatibility, and right now it is uh, cutting this output which is known to us at this particular point. So this will be our final answer. So this is B dash. Next, max product, same question, and 0.34 crisp input. This line is cutting at this particular point, so this will be our final answer. And this is the B dash. Now we are going with the single rule with multiple antecedent. Input will be fuzzy. If x is A and y is B, then z is C. Only there is one rule, that's why we are saying it is a single rule. But now multiple antecedent. In the last there is only one antecedent. If x is A, then y is B. But in this case, if x is A, one antecedent, and y is B, another antecedent. That's why these are known as multiple antecedent. Then z is C. Okay, so output will be C. Now what we want to calculate, if x is A dash and y is B dash, then what will be z? Let us see dash. So this we want to implicate. So same, this is the case which we want to calculate, and just we superimpose at this. If x is A dash, this is the cross section point and it is at 0.58. So this is the degree of compatibility, right? And when we are going to superimpose on this, this is intersecting at this particular point, 0.36, right? 0.36. So how this minimum, right now I can explain to you minimum. So we have to consider this one, 0.58 and 0.36, that is both the degree of compatibility, 0.58, 0.36. Out of them we have to consider the minimum, that is 0.36, and we have to slice at 0.36. Therefore final answer will be equal to this one. So this is the C dash. Now I will explain max product. Same question, when we overlap with this one, degree of compatibility 0.58, in this case degree of compatibility 0.36. Right now we are going to multiply both of them. Okay, max product. So in the earlier case we have to took the minimum value out of 0.58 and 0.36, but in this case we have to multiply 0.58 and 0.36, and after multiplication value comes out to be 0.21. Now we have to slice at 0.21. So this will be our final output, that is C dash. right? So this is the only difference, max mean and max product. And right now maximum I am not able to mm, explain right now. I will explain it with the help of multiple rule and with multiple antecedents. So same question, but right now input is crisp. Same, if x is a and y is b, then z is c. So these are the two antecedent, or we can say multiple antecedent. There is only single rule. So right now input is crisp, right, instead of fuzzy. So this when input x is 6.5, then degree of compatibility is equal to 0.81. When input is 8.5, degree of compatibility is equal to 0.36. So we are going to use max mean. So out of this 0.81 and 0.36, we have to consider the minimum value. So minimum value is 0.36. That's why we are going to slice at this level. So final output will be equal to this one. In the next page, max product, again same question. Input x is 6.5, y is 8.5. This is 0.81 and this is 0.36. Now we have to multiply both these value. After multiplication it comes out to be 0.29, and we are going to slice at this particular point. So c dash will be equal to this one. This is our final answer. Now Mamdani max mean for multiple rule with multiple antecedent, and right now input is fuzzy. So rule 1, rule 2, that's why it is known as multiple rule. Multiple antecedent, like in the previous, if x is a1, y is b1, that's why antecedents are multiple. Then z is c1 and rule 2, z is c2. So in this way, and now we want to calculate if x is a dash and y is b dash, then what will be z, that is c dash. So how it will be implicated? So this is the scenario. If x is a1, y is b1, then z is c1. This is known to us. Rule 1, right? Rule 2, if x is a2 and y is b2, then z is c2. Now we want to calculate if x is a dash, y is b dash, then what will be our output? So we are going to superimpose this with this one, and again this with this one. Again we are going to superimpose with this one and with this one, right? So in this slide we are superimpose this particular value at this location. So degree of compatibility 0.86. When superimpose at this, degree of compatibility is equal to 0.36. So we are going to use max mean composition. Therefore minimum of 0.86 and 0.36, that is 0.36. So we are going to slice at particular this level 0.36. Okay, again for second rule we are going to overlap at this position. So degree of compatibility right now 0.58, and superimpose with this one, degree of compatibility is equal to 0.35. So out of 0.58 and 0.35 we have to consider the minimum value, and minimum value is 0.35. Therefore we are going to slash this particular value at this particular position. So now we want to calculate maximum. So because this is the composition of max mean, mean already executed at this particular point. Now we want to execute with the max. So maximum we have to identify the range from 0 to 6. Value will be equal to 0.36. So we will consider this as 0.36. After that this will be comes out to be up to 8.35. So there is a minor difference. So there is a small peak downward. So this will be our final aggregated value. So now in the next slide we will compute max product. Same. Now degree of compatibility, max product, so 0.86 and in this 0.36. So max product, we have to multiply both these value, and after multiplication it comes out to be max mean, max product. Okay, most probably this is the wrong slide, so just forget about this max product. Now for the same crisp input, multiple rule with multiple antecedent. So same, right now just only difference is the x is a1, y is b1, z is c1, again x is a2, y is b2, z is c2. This is known to us, we want to calculate. Now if x is 7, so degree of compatibility 0.28, in this case 0.97. So it is the max mean composition, therefore out of 0.28 and 0.97, minimum value is 0.28. So we are going to slice at this level. Here degree of compatibility 0.14, here 0.99. So minimum value is equal to 0.14. So we have to consider 0.14. So we are going to slice this. After that we are going to aggregate both these value, and we have to take the maximum, right? So in the next slide, so out of this and this we are going to compute, and final answer will be like this: 0.28 up to this particular level 5. So 2 to 5 it will be 0.28, and after this up to 8 it will be equal to 0.4. So in this way we will calculate. For max product, simply degree of compatibility 0.28 multiply by 0.97, so this comes out to be 0.27, right? So in this case 0.14 multiply with 0.99, so final answer will be equal to almost 0.14. So this will be our finally aggregated value. So in this way we can calculate our final values. So this is the concept of Mamdani fuzzy model, using max mean, max product, using single rule, single antecedent, and single rule, multiple antecedent, and multiple rule with multiple antecedent. Crisp input, max mean, single rule with multiple antecedent. Now defuzzification method. So because we want output as a crisp, but aggregated value is not the crisp, because we are going to achieve like output in this fashion, like this. So this is a fuzzy set, but we want to calculate a crisp output. So to take out the crisp output we have some defuzzification methods. And what are the defuzzification method? Centroid of area, bisector of area, mean of maxima, small of maxima, largest of maxima, height method, lambda method. There are various defuzzification methods, right? So centroid of area, at least you must aware about the formula centroid of area. So this is the concept. Bisector of area, bisector of area, this will be the formula you have to take care. Now mean of maxima, mean of maxima, we have to take the minimum mean value of maximum membership value at that particular point. Smallest of maxima, so at this particular point maximum membership value is this one, that's why smallest of maximum. Largest of maximum, at this point and at this point membership value are same, but we have to consider the largest value at point. Instead of this I am going to considering 5 as the largest value, so this will be our largest of maxima. So with the help of example, just I can illustrate to you single antecedent with 3 rules, and input will be crisp. So this question will be asked like this. This is the antecedent part, small, medium, large, and this is the consequent. Antecedent means input and consequent means conclusion or output. Like, so if x is small, then y is small. If x is medium, then y is medium. If x is large, then y is large. So there are three rules. Now what we want to calculate, we will want to calculate when the input is equal to x is equal to minus 3.9, then what will be output, that is y, right? So I draw the scale, and I took the input x is equal to 0.39, and I draw vertical line. When I draw a vertical line for small region, it is intersecting at 0.37, point 3, but for medium it is intersecting at zero point 0.7, right? So zero point 0.3 and zero point 0.7 are the degree of compatibility. 0.3 degree of compatibility will be for small, and 0.7 will be degree of compatibility for the medium. But this input is not engaged with this particular section, large, so this will be not applicable, right? So for input, this degree of compatibility for small will be 0.3, and for medium it is 0.7, right? So in this case there are three rules: small, small, medium, medium, large, large. So when I, if there are only three rules, but rules will be applicable, only first and second rule will be applicable, because this input bisect small and medium part, right? That's why, because it is not engaged with this particular area, therefore rule 3 will not be fire. So this will rule will be obsolete, right? Now how to calculate? So this will be at 0.3, so this will be our particular, we have to cut small region at this particular level, and medium region from 0.7, and after that we have to take the maximum of this. So this and this will be combined. So this is the first case, this is the second case, and we have to again combine this. After combining this, this will be our final output, but it is aggregated fuzzy output. Again we have to calculate a crisp output, so we have to apply defuzzification techniques. So using centroid of area, the defuzzification value, that is crisp value, equal to 3.6327. When we apply bisect of area, so our output is equal to 3.7087, right? And when we apply mean of maxima, our output is 3.8789, and when we apply smallest of maxima, our output is equal to 2.1. When we apply this largest of maxima, that is this one, our output is equal to 5.596. So normally we avoid smallest of maxima and largest of maxima, or mean of maxima. Generally we go for bisector of area or center of area. So in defuzzification, for the every defuzzification technique, output is difference. So normally we avoid SOM, LOM and MOM. We can go for bisector of area, and another one is the center of area. So this will be our final output, looks like this. So again, for this is another example, just I am stopping. So this is the overall concept of Mamdani, and now in the next video I will discuss Larsen model. And now because you already aware about the Mamdani, so in the Larsen model, that will be very simple to you, and you can easily grab. So thank you so much.